also discuss any individual questions that would come from your presentation.
Okay,
So,
basic, can you hear me?
Yes, I can hear you.
Okay, pretty with file I open. Okay. Okay, so thank you for having me, Jessie. Maybe the video is a bit blurred, so later we will also share our YouTube link. So hello all the audience, brilliant partners. I'm very happy to be here to introduce Trina Solar solution to lower the LCOE for Malaysia's solar development. Please allow me to take 1 minute to introduce Trina Solar. Trina Solar was founded in 1997 with 23 years history and IPO in New York in 2006. And this year we listed in China stock. So as we all know, Trina's main business is manufacturing the high efficiency solar modules. Also, we provide a system solution as a manufacturer of tracker and also the utility project developer. And in the future, we will also go for the smart energy system. As a manufacturer, Trina total shipped more than 60 gigawatt module to more than 100 countries. We have 5 factories in China and 1 factory in Vietnam and 1 factory in Thailand. And as a tracker manufacturer, Trina total provided more than 2 gigawatt shipment. And as a developer, we grid connected more than 3 gigawatt projects already. And for our Asia Pacific, the HQ located in Singapore with more than 6.5 gigawatt shipment from 2017 to first half of this year. And around 4 gigawatt is for utility project and 2.5 gigawatt is for residential, commercial and residential projects. And Trina is also considered 100% bankable brand from 2016 until this year. Okay, so go back to today's topic about the LCOE. So from this formula, we already know the LCOE is determined by various factors like the total cost and the total power generation. And the BOS plays a very critical role, and the BOS is determined by the module power and the module efficiency. The higher module power and the higher module efficiency can lead to the lower BOS. Also, from the curve below, you already can see this is a power increasement curve. So it's a very interesting point that from 2019 we can see actually the power increase is it's not so much, like every year around 10 to 20 watts. But after 2019, let's say we are from 410, and each year we can increase around 50 watts. And in the future now it's like every year is around 100 watts. So it's a very huge development for the module efficiency. So we can see like early this year, Trina launched the 500 watts. And November, we launched the 550. And the next year, we will go for the 600 and the 660 for large scale solar. And now in Malaysia, we all know, let's say, the large scale solar called the LSS and Rooftop all develop very, very fast in Malaysia. So for the later presentation, I will also introduce from two ways on both for LSS and Rooftop projects, see how Trina can provide the lower LCOE. So from this slide, this is a solution for solar farm project. Now the module already went to the 600 plus wattage era. To lower the LCOE for solar farm projects, we will provide our high efficiency module from 550 watt to 600 plus. And next year we will go for 680 watt like I introduced, with a more than 21% module efficiency. So compared to the traditional module, the single string power, we can increase more than 40%. Besides the module Trina, we also can provide the tracker with the smart energy system. Trina Pro system boasts itself with an intelligent tracking system, hardware system design, software function, integrated service, and smart O&M service. So here, this is our brief introduction about the 600 watt plus module. The core technology, and which is also the remarkable technology for our Vertex series module, is a low voltage and high string power. So we can see the voltage is around 38 voltage. So here, from this table, we can see if using the low voltage module 550, one string can connect around a 36 piece module compared to the 27 piece of the reference module. One per string can connect around 35.8% more power. So which per string power is a critical factor that impacts the cost of balance of BOS. So how can it convert to the BOS, or we said the LCOE savings to save the LCOE? So we can check from the one project. What is a 100 megawatt project in China with a 1,500 voltage centralist inverter is a fixed mounting structure backsheet module. So let's say if we use a low current, low voltage module, for 550 watts, one string can connect a 36 piece module. The reference module 540 can connect around a 27 piece module. So from the total overall calculation, it can save around 9% of the ranking, 10% on foundation, 4% on cable, 26% on combined box, 4% on installation, and around 1.7% on the module quantity. So overall, the BOS system can save around more than half cent per watt for the total system cost. And also another more comparison done by the third party DNVGL. This is it's also a 100 megawatt project in Spain, but it's used a bifacial module, string inverter, and a tracker system. So we can see the same if we use a 545 watt module per string connect around the 35 piece, and for others from 410 until 335 watt module, one string can connect around the 26 to 27 piece. So overall, we can see for the BOS, if we compare 545 and the 450, the BOS can save around 6.5%, and the LCOE can save around 2.8%. So this is the situation in Spain. And also we work with the DNVGL on another project on 100 megawatt in US. The same, we use string inverter with a tracker system. And I found out actually the BOS can save around 6.3%, and the LCOE save around excuse me, 3.5%. And also for besides the P-type module, we also can provide the N-type, which will mass production end of next year or 2023. Just now we introduced is for the LSS, and also we do have the solution for the rooftop. Actually, because the installation site is different, the module installed on the rooftop will be slightly different from on the large scale solar, because on the rooftop, the module will be more focused on the convenience and the safety. If you use the too big or heavier module, actually it will have lots of the safety issue. Let's say it will be very hard to carry or transfer the modules from ground to rooftop. So if during the transfer, it may have the invisible micro crack issue. And also it will increase the mounting structure cost because the module is too heavy or too big. And also maybe during installation, it has a safety issue. So we can see, let's say for normal humans, the height is around 1.7 meter. We provided 4 solutions for the rooftop project. One is Vertex S system. It's around 21 kilogram, and the height is perfect for the human height. But the module efficiency is also around 21%. So it's very perfect for the residential or small CNI project. And another 2 solution is for 450 and 500 watt. The module efficiency around 20.6 to 20.9. And the size and the weight are still very suitable for most CNI rooftop projects. But when we go for the 550 watt, because the size is it's very long, it's around more than 2.3, and also the weight is around 29 kilograms. So for safety issue, we only recommend for some special CNI project. So we take example as one rooftop. So we can see because the rooftop, the space is very limited. We use different models. Actually, the capacity we install will be different. So let's say if for this kind of rooftop, if we use Vertex S, actually you can increase around 10% on the installation capacity. Okay, so this is around the LCOE, what we can do for the rooftop projects and for the LSS. And lastly, I would like to share some of our project reference in Malaysia. These are some bigger solar farm we did for LSS in Malaysia, and also some rooftop projects. And these are some projects in USA, in Australia. Okay, so thank you for the presentation.
Thank you, Elva. Thank you so much. Let's kick off our next presentation.